Greetings, math fans. All right, so this is another day of solving trig equations, and they get a little trickier. A couple things we're looking for. We're looking for identities, cross multiplying, a lot of different things. So I just have a bunch of examples to do with you guys, and let's go. So our first problem is cosine squared of theta equals sine squared of theta plus 1. So with this problem, you should kind of look at it and say, oh, wait, I got a cosine squared and sine squared. Now, you can't mix those together because it's like mixing cats and dogs or fire and rain, unless you want to set fire to the rain. Okay, but you can't mix those together. So you have to kind of think, is there any way I can just get a sine all by itself or cosine? Well, again, recognize you see a cosine squared. That's Pythagorean identity, right? You can say 1 minus sine squared. Or I could do the same thing. I'd say sine squared is 1 minus cosine squared. Either one will work, give you the same answer. So just for the heck of it, let's just do 1 minus sine squared here. And that's equal to sine squared of theta plus 1. So if I move this guy over, I get, I'm going to keep it on this side, so I get 2 sine squared of theta, and I move the 1 over here, so I subtract 1, I get 0. That's pretty sweet. So I wind up getting sine squared of theta after divide by 2, I get that equal to 0. So of course take the square root of both sides, I get sine of theta is equal to 0. All right, and how many answers do I have for that? I have 2 answers, right? I have theta is equal to 0 and pi. Okay? Pretty straightforward. Okay, let's keep going here. So it's a little trickier. Cosecant of theta minus cotangent of theta equals 1. Now, this is what you need to do, math fans, is you kind of need to recognize when you see a cosecant and a cotangent, you should think, oh, wait, I could probably do something with the Pythagorean identity. I certainly can't do anything with this now. All right, the way it is here. Maybe I could change it into sines and cosines. Sometimes there are a lot of different ways to do this, but if I could get a cosecant squared and a cotangent squared, I can kind of simplify. I could do some substitutions, right? So I could square both sides right now, but what happens is you would get cosecant squared of theta minus 2 cosecant cotangent plus cotangent squared. In other words, it looks kind of messy. So if you would move, I'm going to move this cotangent over, so I'm going to add cotangent of theta to both sides. If I do that, I get cosecant of theta equals cotangent of theta plus 1. Now if you square both sides, it actually is a little bit cleaner because I get cosecant squared of theta, and this one I get cotangent squared of theta plus 2 cotangent of theta plus 1. And now this is all in terms of cotangent on the right side, and of course you know our identity for cosecant squared of theta is cotangent squared of theta plus 1. Sweet! Sweet! Okay, so then we're going to write everything out here. And then I'm going to subtract cotangent squared of theta and subtract 1 from both sides. And if you do that, that cancels and that cancels, right? And I just have 2 cotangent of theta equals 0. That's pretty sweet. Divide by 2. So I have cotangent of theta is equal to 0. Okay, and then, of course, you guys remember cotangent. Tangent is 0, undefined, 0, undefined, and cotangent is the opposite, so it's undefined, 0, undefined, 0. So the answer for this one, let's do this one in degrees, is going to be 90 degrees and 270 degrees. Okay, everybody good? Pretty easy problem, right? Okay, let's move on. Not quite yet. All right, you can't move on, and the reason we're not going to move on is, you see this? I'm going to highlight this. See this right there? See that? Okay, we squared both sides. Whenever you square terms in an equation, you can basically create they call it extraneous solutions. So you have to check for those. Okay, you got to check for extraneous solutions. And some of you guys are like, well, I don't understand how an extraneous solution can even occur. Well, let me just give you a really basic example. If I set x equals 5, I have one answer, x equals 5. But if I square both sides, I get x squared equals 25. And now if I ask you to solve it, what do you get? Well, don't you get x equals plus or minus 5? I've just introduced an extra solution, negative 5. So I'd have to go and plug that in and check it. So if I plug in a 5, 5 equals 5, that's true. If I plug in negative 5, and negative 5 does not equal 5, so I have an extra solution. So whenever you square a term or multiply by a variable, like let me give you the same example, x equals 5. If I multiply both sides by x, I get x squared equals 5x. If I move the 5x over, don't you factor out an x? And don't I have two solutions, x equals 0 and x equals 5? So the only one that really would have worked is 5. 0 is an extraneous solution because I multiplied it by a variable. Okay, so it doesn't always give you an extra solution, but you do need to check. So let me erase the side stuff here, and we can check. All right, so in order to check, you have to plug the answers into the original problem. That is really, really important. So you got to plug it into this original guy right here. Because let's say you changed it into sines and cosines, and you did some work, and you plugged it back into the sines and cosines, you might get a different type or different extraneous solutions, or they may not turn out to be extraneous solutions because aren't sine and cosine always defined, and secant and cotangent are not defined at some places. So that's why you got to plug it back into the original problem, not whatever you modified. So very, very first problem. Okay, so let's plug that 90 in there. Cosecant of 90 minus cotangent of 90, and we're seeing if that equals 1. Well, cosecant is the same thing as sine. Sine of 90 is 1, so it's reciprocal of 1 is 1. And cotangent, well, I just drew this chart right here, right? This is for cotangent, and cotangent of 90 is 0. So 1 minus 0 is equal to 1, so that's good. So 90 is a good one. Okay, and then let's do the other one. Cosecant of 270 minus cotangent of 270, and does that equal 1? Well, cosecant of 270, sine of 270 is negative 1, so reciprocal is also negative 1. And then again, cotangent, we're down here, so that's equal to 0. So negative 1 minus 0 does not equal 1. So 270 is out, so my only answer is 90 degrees. Okay? Make sure you check for the extraneous solutions whenever you square it. If you don't square it, you don't need to check. Don't be doing extra work when you don't even need to do the extra work. Okay? All right, so let's move on to another problem here. Oh, that's a good problem. They're all good problems, believe me. Okay, 1/2 cosine squared of 2x minus 3 equals 0. All right, so I'm solving for cosine of 2x, right? So I'm going to add 3 to all sides. So you get 1/2 cosine squared of 2x equals 3. Multiply everything by 2. So cosine squared of 2x equals 6. Then I take the square root of both sides, and I get cosine of 2x equals plus or minus. Don't forget the plus or minus 6. So the question, oh, this is a double angle. It's nice, right? But the question is, the cosine of what is root 6? Okay, and I know you're all thinking, you're like, gee, I don't really know. Well, the reason you don't know is because there isn't any value. Well, there's no value that we learned, right? We only learned, 1, root 2 over 2, root 3 over 2, 1/2, 0, but we didn't learn anything about root 6. But what I want to point out is the cosine, remember this ratio, when I said like cosine of 30 degrees is root 3 over 2? Right, this value is always, the biggest value is 1. Isn't that always between negative 1 and positive 1? Always, 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 right? And so what is root 6? Well, root 4 is 2, and root 9 is 3, so it's somewhere between 2 and 3. So it's impossible. There's no way you could take the cosine of something to get you that big of a number. It's got to be between negative 1 and 1. So this one is NSB. No solution, baby. Okay, because that is greater than, basically it's greater than, or if I take the absolute value, it's greater than 1, and it can't be. Okay? All right, so let's keep going here. Sine of 2x equals negative sine of x. So this is exactly the same thing as I talked about before. You can't mix cats and dogs together, or rain and fire, or whatever, hot dogs and I don't know what doesn't go with a hot dog. Hot dogs and steak. Okay, so you can't mix that stuff together. So you have to look to see if you can simplify, because this is like a double angle and a single angle. All the single angles? Okay, you can't do that. So anyway, I am going to recognize that sine of 2x can be 2 sine of x cosine of x equals negative sine of x. Sweet. So I see a potential where I can factor, and I'm going to do that. I'm going to add sine of x to both sides. So I get 2 sine of x cosine of x plus sine of x equals 0. Okay, so now I'm going to factor out a sine of x. And I get 2 cosine of x plus 1 equals 0. Pretty sweet. So I get sine of x equals 0, and 2 cosine of x plus 1 equals 0. So this one I can solve easily. Sine, let's do it in radians. So sine of what is 0? It's going to be 0 and pi. Pi. And this one is going to be cosine of x equals negative 1/2. And your reference angle here, right, is going to be pi over 3, 60 degrees, right? And we're in these two quadrants because it's negative. So x is going to be 2 pi over 3 and 4 pi over 3. Yeah. Okay, we didn't square anything, nothing fancy, and so those are our 4 answers. Okay, not bad. Let's keep going here. It's a great problem. I say that about everything, don't I? I love math. So sine of x, cosine of x equals 1/4. Okay, so that you can't. This is like a really bad algebra mistake. Is to say sine of x equals 1/4 and cosine of x equals 1/4. You can only do that if it's equal to 0. Don't mess it up, guys. It's brutal to do that otherwise. Okay, so if it's sine of x, cosine of x equals 0, then I can set each from equal to 0. Because you can't set sine of x equal to 1/4 and cosine of x equal to 1/4. It only works with 0 because the 0 cancels the other term out. Okay, so look at what sine of x and cosine of x, what can I do? Well, boy, this is really close to 2 sine of x cosine of x, which allows me then to turn into one function. So if I multiply both sides by 2, I actually get a double angle for sine. Oh yeah. So I get sine of 2x equals 1/2. That you can do. This is what we learned yesterday. Okay, so remember you're going to say 2x equals, well, sine of what is 1/2? And you're going to say, oh, it's pi over 6. And, well, of course, we're in these two quadrants here. So it's pi over 6 and 5 pi over 6. And then, of course, I add to both of those 2 pi. So 2x equals, right, 2 pi is 12 pi over 6. So I get 2x equals 13 pi over 6. And 2x is equal to 17 pi over 6. All right? So now we're not done yet, right? You got to multiply that whole thing by 1/2 because you got to solve for x. Really, really important. So that's really easy now. You get x equals pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay? Not bad. Now it's funny, back in the day, again, you try different things, but I think one time I tried to square both sides. I got sine squared and cosine squared, and man, when you square it, all of a sudden it's brutal looking because you have sine squared, cosine squared, and then you try to substitute one of those for 1 minus sine squared, and you wind up getting to the 4th power, and it's brutal. People want to cry and drop, and it's just not a pretty sight. Okay, so this was a nice double angle problem. All right, couple more here, math fans. Let's see. Oh yeah, here's an exciting one. 2 sine of theta equals 2 cosine of 2 theta. Okay, 2's cancel. That's pretty easy. You can always do that. Remember, you can always cancel a number, just can't cancel a variable. So again, you got cosine of 2 theta. What are we going to do here? Okay, we're going to change it from a double angle to a single angle. Now, of course, it's in terms of sine, so you're going to do, we have sine theta, and this is going to be, of course, 1 minus 2 sine squared of theta. That makes sense, right? And then I'm going to move this over to the other side because I want to get a positive leading coefficient. It's just easier to factor. So you got 2 sine squared of theta plus sine of theta minus 1 equals 0. So remember, math fans, this is just a nice little factoring problem, and it's 2 sine of theta, and this is going to be plus 1 and minus 1 to work out for factoring. Okay, equals 0, and then of course you set that equal to 0, so you get sine of theta equals 1/2, and sine of theta equals negative 1. And 1/2, a reference angle, of course, is pi over 6. We're in the first two quadrants, so you're going to say theta is equal to pi over 6 and 5 pi over 6. And where's theta equal to negative 1, sine theta equal to negative 1, it's at 3 pi over 2. So that's equal to 3 pi over 2. Okay, pretty good. Okay, 2 more. Sine of 2 theta equals 2 cosine squared of theta. Looks kind of similar, but not quite. Definitely got your double angle, so I'm going to change this to 2 sine of theta. Cosine of theta equals 2 cosine squared of theta. Now, do you guys agree the 2's cancel? And I'm going to move, it looks like I'm going to have to factor, okay? To change that cosine squared to 1 minus sine squared, it's not going to help me because I have sine and cosine on the left-hand side anyway, so it's not going to do anything. But I can factor here. If I move this over, I get cosine squared of theta minus sine theta cosine theta equals 0. Right, and I'm going to factor out a cosine of theta. So I get cosine theta minus sine of theta equals 0. So I get cosine of theta equals 0. And I get cosine of theta minus sine of theta equals 0. So this first one's easy. Where's equal to 0? We'll do degrees this time. So 90 and 270. Okay, that one's pretty easy, right? And this one's like a little bit more challenging. And, you know, again, I kind of learn as I teach, like, different ways to do it. I think the first time I did this, I squared both sides, so I get a sine squared, cosine squared. And that kind of turned out pretty messy, because whenever you square, you got to check for extraneous solutions. So what I did is I thought, well, what if I just move sine over? And then I divide both sides by cosine of theta. Sweet! So this is equal to tangent. Tangent of theta equals 1. That's so much easier. And so where's tangent equal to 1? Well, it's in the first quadrant, 45 degrees, and in the third quadrant, 225 degrees. And there you go. Those are your 4 answers. I didn't square anything, so I didn't have to check for extraneous solutions. Oh yeah, love it. Okay, last example. Secant of theta plus cosecant of theta equals 0. It doesn't do any good to square both sides here. And the reason is because secant and cosecant don't go together. They're not a Pythagorean identity. They're reciprocal identities, but they're definitely not, or no, I'm sorry, they're not even reciprocal identities. They really don't have anything relation at all, right? So what I would do is change it into sines and cosines. It's kind of what I would look at. All right. If this would be 1 over cosine theta plus 1 over sine of theta, right? And again, to try and get a common denominator, you're going to multiply cosine, this one by cosine, this one by sine. That's almost a little messy too. And again, one reason it's messy, it'll work. But as soon as you start multiplying by stuff, you got to check for extraneous solutions. So maybe you look to see if you cannot multiply by something. And in this case, what happens if I move this over? Move this guy over to the other side. That happens a lot. 1 over cosine of theta equals negative 1 over sine of theta. And then what can you do here? I can cross multiply. Right? If I cross multiply, it's not multiplying it by a variable, and you don't have to check for extraneous solutions. So I get negative cosine of theta equals sine of theta. And this looks like similar to a problem we just did. I'm going to divide both sides by cosine of theta. And I wind up getting sine over cosine, so that's tangent of theta equals negative 1. And then let's do radians for this one. Well, isn't it in the second quadrant, which is 135 degrees? And the fourth quadrant, 315 degrees. And those are your 2 answers. Okay? So kind of the idea is if you have a double angle, look to see if you can change it into a single angle. Okay? If you have a Pythagorean identity, look for those. And if you don't even have a Pythagorean identity, like for example, we had the secant and cosecant, sines and cosines. If you see secant and tangent, that is a potential Pythagorean where you move one side and you square it. Or you see cosecant and cotangent, sine or cosine. If you see any of those kind of together, those are definitely Pythagorean identities. Okay? So just trying to give you guys a little helpful hint on how to, simplify some of these. So anyway, those are all my examples, math fans, and hopefully you guys are good to go with this stuff. All right, that's it. Have a good day. Adios. Goodbye.